Hi friends, I'd like to talk in this video a little bit about graphing exponential functions. And just like graphing any function, it can be useful to make a table of values. So just a quick reminder that an exponential function is a function in which the variable is in the exponent. So here we've got 2, the base is 2, raised to the x power will give me y. Or you might also have it in function notation where f of x would be equal to 2 to the x power. So for an exponential function, when you put in your x values, it's going to go into the exponent. So as I evaluate for each of these y values, when x is negative 2, I've got 2 to the negative second power, which is the same as 2 to the second inverted, or 1 over 2 to the second, or 1 over 4. Remember, the negative exponent means to take the reciprocal of the base, so it's 1/2 squared, or 1/4. 2 to the negative first is, of course, 1/2. And anything raised to the 0th power is 1. So we might need to come back to that in a second to talk about. 2 to the first power is 2, and 2 to the second power is 4. So again, just taking a look, these are replacing the exponents for each of these operations. Okay. So then I've got points, right? Each of these represents a point that I can plot on my graph. The x value here being negative 2 for the x coordinate and 1/4 for the y. So I have the point negative 2, 1/4. Here, the point negative 1, 1/2. Here, the point 0, 1, 1, 2, and 2, 4. So I'm going to go in and just graph these points and start to think about what the shape is really going to look like. So at negative 2, I'm at a 4/4. At negative 1, I'm at a 1/2. At 0, I'm at 1. At 1, I'm at 2. And at 2, I'm at 4. So now, of course, we want to be able to think about what is the general shape of this graph going to look like without hopefully having to plot every point in the direction, right, in every direction, because that will just take an infinitely long period of time, and I don't have that. So let's think a little bit about what is happening as these exponents get more and more negative, right? As I get to, I don't know, maybe if my x value is negative 10, what would my y value be? Well, I'd have 2 to the negative 10th power, which would be 1 over 2 to the 10th power. So that's a fraction. That's a small fraction. It's closer and closer. It looks like it's getting closer and closer to 0, right? It's getting smaller and smaller. So like at 10, it would be really, really close down here. Could I think of a number? Is there a x value, a negative x value that I could put in, like, I don't know, negative 2 million, that if I put in would make my y value become a negative output? Pause and think about that for a moment, maybe. And I hope that you'll realize that because these are replacing the exponent, right? You've just got 2 to the negative 2 millionth here. That's the same as 1 over 2 to the 2 millionth, which is just a really big number in the denominator. And so the bigger the number in the denominator, the smaller the value is. But that value is never going to be equal to 0, and it's never going to become a negative, which means that this graph is going to get closer and closer and closer to this line, this y equals 0 line, without ever actually being able to touch it or cross over it. And that's a working definition of a horizontal asymptote. It's a line that your function is coming closer and closer and closer to, and unlike my image there, is never going to be able to touch or pass over. It's a little hard to draw here with the computer, but it's just getting closer and closer and closer, okay? So that's what that behavior is going to look like. It's just coming closer and closer without ever crossing over. And I'm struggling to draw it, so I'm just going to stop there and put an arrow. But you have the idea. So this horizontal asymptote is at the line y equals 0, which means that something weird is happening about the range, right? I can't include any of these y values in my graph. So the range for this has a lower boundary, right? It's bounded by 0. It can't actually be 0, so I'm not going to use an inclusive bracket. But it's bounded by 0 on the bottom. But then I think it's going to go up. So let's think about some really big numbers, right? Like what if I raised it to the, I don't know, 5th power? Well, 2 to the 5th power is 32. So at 5, 1, 2, 3, 4, 5, I'm going to go up 32. Well, that's like way off the top of my graph, right? Even at 3, I'm at 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8, right? At 4, I'm at 16, so that'd be sort of somewhere up here. And so as these x values go up, there's nothing really to stop them ever going up. So they're just going to sort of go up increasingly steeply. We sometimes say exponentially. Interesting. All the way up to positive infinity. Okay. The domain of values, there's nothing to limit the x values that I can put in here, or and these, even though it's getting steeper, it's still going further to the right with every step. So my domain is from negative infinity to positive infinity. Okay. And so that's an example of the parent function of y equals 2 to the x. This is called a growth function. It's growing away from its asymptote. And remember we said that we were going to take a look here at this 0 value, right? We noticed that at 2 to the 0, we're one step away from our asymptote. So that might be interesting later on. Okay. Let's take a look at a couple of other functions here where I'm just doing a little transformation. I'm taking that same parent function, 2 to the x, and I'm just making a little adjustment to it. I'm adding 3 here. And just because I had so much trouble with the drawing of 2 to the x, I picked a graph that already has that graphed in here. So this is the graph of y equals 2 to the x, or the parent function. Okay. So now I'm going to graph y equals 2 to the x plus 3 in this on the same graph and just see what happens. So let's just grab a couple points just to get an idea of what's happening. So at -1, I get 2 to the negative first plus 3, which is a half plus 3, or 3 and a half. At 0, I have 2 to the 0th plus 3, which is 1 plus 3, or 4. And at 1, I have 2 to the 1st plus 3, which is 2 plus 3, or 5. So let's take a look at where those points are going to be. So at 0, I'm at 4. At 1, I'm at 5. At -1, I'm at 3 and a half. Okay. At -2, I'd be at 3 and a quarter. Right? So these are going to come closer and closer and closer down. And these will come steeper and steeper up, right? Just like that parent function. So notice now all of a sudden that my asymptote, the thing that I'm getting closer and closer and closer to, is no longer 0, y equals 0. Now the thing that I'm getting closer and closer and closer to is up here, right? At y equals 3. So my horizontal asymptote has shifted, right, up 3 places. This is now where my line is approaching without ever touching. Okay. And if I were to connect those, again, carefully here, it's more challenging than it looks. Notice I have the same shape, but the whole shape has just been shifted up 3 values. Okay. If I take a look at another example, do this one in different color, 2 to the x minus 4, if I go ahead and plug in some values, 2 to the negative first minus 4 is 1/2 minus 4, so that's negative 3.5. 1 minus 4 is negative 3, and 2 minus 4 is negative 2. So let me plot some of those points. So at 1, I'm at negative 2. At 0, I'm at negative 3. At negative 1, I'm at negative 3.5. If I went to negative 2, I'd be sort of here, right? I'm getting closer. At 2, I'd be at 2 squared is 4. 4 minus 4 is 0, so at 2, I'd be at 0. 3, I'd be 8 minus 4, so 3, I'd be up here. Okay. So now take a look at that shape. And take a minute and think about what that shape looks like in relation. What would the asymptote be for this one? Where does that line come through? And hopefully you notice that the asymptote there is back here at y equals negative 4. So hopefully you're observing that this value is shifting our asymptote up or down, and with it the graph of our parent function, 2 to the x. Okay. If I go back, let me just label these quickly so that you know which one is which. So up here, this is y equals 2 to the x plus 3. And this one down here is y equals 2 to the x minus 4. Okay. So if I go back and think about the domain and the range, the domain for this one, well, it's going from negative infinity to positive infinity. The range, though, it's always got to be larger than 3. So the smallest value could be is 3, and that horizontal asymptote is at 3. For this one, the domain is also from negative infinity to infinity. The range is bounded here by negative 4. So negative 4 is the smallest that we could ever be. And our horizontal asymptote is that negative 4 as well. Okay. In a subsequent video, I'll show you a couple of other transformations that are interesting to look at, and what happens when we change this base value from 2 to something else. But I hope that gets you some information on starting out with graphing exponential functions. Thanks.